break. Okay. I said I'm not for chain. I'm Mike Claron. I manage the group building service applications. Makes more sense to talk about that than Peter. Peter did say, though, that if you have any questions on this topic, you should feel free to call him anytime, day or night, and be happy to do it. I'll put that up here in a minute. I also understand that I am the last thing before the break, so I'll try to be quick. But stop me if you have any questions. So what I'll talk about is which server applications we're doing, and at a high level, how they're put together, and from that we can derive what the customization story is. We'll look at the technology and see how you can use technology to pull it apart a little bit and reassemble it in a different way to meet the needs of individual NetOps. So first of all, when I say applications, what I mean are server applications, which is pretty traditional web-based applications. URLs come up, HTML goes down. These are not applications that are built into the client like EPG. So the list is web home, centers, mail, although this actually isn't being done in my group, it's being built in a similar way. Favorites, the search application, help, registration, which is the application that guides you from having a brand new box in their living room to actually being signed on to the service, and some application which is actually broken out into two separate ones called settings and account. So these are the applications that are covered by what I'm going to talk about. And now what I want to get into is how they're put together. So the basic idea is, here's your TV, here's your set-top box, cable, no antenna, sorry. I've been drawing it that way for a couple of years, but that no longer applies. Some cable connectivity. This represents an application on the back end. An application is a COM object. The flow of information, as I said, is URL go up from the box. We send HTML back down, and then it shows up on the screen as something. And that's basically what our applications do. In a little bit more detail, the URLs that come up this is an example of what one looks like, WTV NT favorites, / folder list. So this part identifies which application COM object the request get routed to. Everything after that is specifics about what that request is asking to do. So you can imagine that requests for the mail application would be, show me what mail I have in my inbox, show me message 27, reply to message 82, things like that, encoded as URLs coming up. The HTML comes down is more detailed than we want to get into, but that's pretty much everything that's supposed to go on the screen. You might look at this and wonder, let's see, this URL doesn't tell me which user this is for. There's a lot of users that have favorites, and they all have folder lists. So implicit in this diagram is another thing called the ticket, which I trust someone has talked about. Has anybody talked about the ticket before me? Okay, good. So the ticket is sort of like a magic cookie-like thing that has extra information, including which user we're talking about, which box, other things like that. So that helps us figure out, on this side, how to respond to this request that comes up. In a little bit more detail, so we will we'll zoom in on part of the picture. What this looks like is, by the time this request gets to my object, it's already been parsed and decorated and turned into an XML tree. That XML tree comes into this process. There's like some Batman-like machine. The XML goes to the hopper, and what comes out is new and better XML, and that goes into some other process, another little conveyor belt thing, and out comes HTML. So, make this a little more clear. This is the raw request. It's basically the URL and getting some other information parsed into a single data structure that's XML so that our applications know what to do with it. This is the application C++ code embodied as a COM object. So for this particular request, show me my folder list. It gets parsed to XML. All the parameters and the ticket data is in the tree somewhere. The C++ code gets it, chews on it for a while, looks wherever it needs to look to figure out what folders you really do have in your folder list. Looks in the user store, looks in the database, or in the case of the mail application, it reaches out and looks to Hotmail. But this gadget here does whatever it needs to do to answer the question being posed by this request. And the interesting part of the architecture is that rather than going directly to HTML, we represent the answer in an intermediate form as more XML. So maybe all these blue nodes were already there in the original request. Who's asking, what they're asking for, properties of the service upon which they're asking this question. Those are still in this tree. We've gone and actually answered the question. The user with this ticket in his folder list has folders A, B, and C, and inside folder C there's favorites F1 and F2 and F3. So we come up with a rich XML representation that is really the request and the response, still not in form that a human being would necessarily want to look at. We feed that into our rendering engine, Jinx, comes HTML, and that's what gets sent down to the service. So this whole thing is what happens if you open up the hood on that and look inside. So Jinx. Jinx is an interesting beast. So we'll talk some about Jinx, but one of the myths I want to dispel is that our applications are written in Jinx. They use Jinx, but there's actually a lot of other things going on. So if you took ASP and XSL, two famous Microsoft acronyms, and put them in a blender, you'd get something very much like Jinx. If you open up a Jinx file, what you see, so we'll expand this. Here's some simple Jinx. So, like ASP, Jinx is essentially HTML that has been marked up with embedded script tags, and those script tags get evaluated on the server side before this HTML is sent back down to the client. So, and if you actually look at a Jinx file in Dev Studio, it actually hides these things in yellow. My whiteboard technology can't quite display it that nicely. But anything in a green box is a Jinx command embedded in this HTML. Green stuff gets evaluated and it gets sent down. So this is saying if this data is in the XML tree, if it's in the XML tree that this Jinx is rendering, then spit out hello, otherwise spit out goodbye. The whole thing is wrapped up as HTML and sent down. So Jinx has, let's see, the interesting attributes of Jinx are, like I said, HTML with embedded script. It has ASP style delimiters, this less than %, greater than is familiar to anybody who's done ASP coding. Very similar syntax. And it has, so this is sort of like ASP-like. And this part here, which is go look in an XML tree for some data and then make some decisions or render based off of that, that's derived from XSL. I'm writing exceptions up here so that if I have time, I'll remember to come back and talk about that. This is the way most of our applications work. There's things that are different. I'll come back to that if I have time, but I don't want to keep you from your cookies. So a question that we've been hearing a lot is, why do we do this? Why did we go and make Jinx? Why do we invent this whole new language? Because Jinx is something that exists only in Microsoft TV Server. The answer is because the other candidates tried ASP and XSL had problems, and we had to address those problems, and we couldn't do it within the framework of either of these two languages. For ASP, the problems basically boiled down to the performance scalability wasn't there for the type of massive customer base that we're anticipating supporting, and the localization and customization story, which are really fast at the same thing, and I'll get into that in a few minutes, wasn't strong enough to do what we wanted to do. A little more detail. TV Pack has a huge range of different customers. One installation may support people with NTSC TVs, HAL TVs, 16:9 TVs, 5 different countries, 8 different languages, 2 or 3 different levels of service, 3 or 4 different clients, and it has to vary the HTML that it sends down based on each of those axes. And ASP just really wasn't up to the task. XSL is an interesting technology. If you ask what XSL does, it does exactly what this little box does here. It takes XML in, who's on it, spits out HTML. And we tried for a long time, a long and painful time, to make XSL work for us. And the problem we encountered with that was that even though it looked good architecturally, it's actually very promising for certain class of problems. It didn't quite go all the way for us. Basically, the first 8% of what we wanted in XSL was beautiful and easy and simple, and the last 20% was just flat out impossible. You could not get there from here. Try as we like. XSL is pretty good at rendering pages up to a certain level of complexity, but our pages were more complex than that. Excuse me. I said that there was a myth that our applications are developed in Jinx, and I want to explain that in a little more detail. Jinx is just the final step in a processing pipeline, and it is one of many technologies that go into servicing this URL. So saying that Jinx, our applications are in Jinx, is kind of like saying cars are made out of paint. When you look at a car, you see paint on the outside, and maybe that's stretching it too much, like maybe saying that cars are made out of paint and sheet metal. So that's largely true. You know, you can't make a car without paint and sheet metal, and paint and sheet metal really kind of defines what a car looks like, but a car isn't going to do you much good without wheels, transmission, engine, things like that. And the analogy here is, you know, we're the sheet metal and paint, but things like the user store and the database and something called the server manager and the logging system and the configuration system and a whole bunch of other technologies are what this thing does to actually answer the question. So when it says, go get me my mail or go look in my favorites, this process here is doing a lot of work representing it as XML. This is just drawing it. Now, a lot of pages on a website are just drawing. So for a large number of things, this doesn't do very much. Like you can imagine for the instructions application or the help application, the thing that says, you know, this is how you put a favorite into a folder, this is very little or nothing. But for a lot of applications, this is pretty substantial. Yes?
Jinx is working like a filtering program, basically.
It's output. So we have data, and we have worked on representing all our data as XML, and that's good sort of like process-to-process communication. No human being wants to look at XML. So the last is to just present that data on the screen in HTML. So like I said, for favorites, this would be like nodes representing each folder, nodes representing each favorite. Each of these would have maybe a name and a thumbnail. So it's just a tree that represents the data, which is fine conceptually, but not what the user wants to see. So this last is just what walks through the tree and says, for each folder, I'm going to draw a little tab on the screen, and for each favorite, I'm going to draw a thumbnail and the name and get a link, and that's what Jinx does. We have for loops that do exactly that. If you opened up our Jinx files, that's what you'd see. I'm out of board. I wanted to zoom in a little bit more on this part. I'm going to wipe this out because this isn't very interesting. So I'm going to explain a little bit more what the internal structure of this is. The purpose of that is to start explaining how people can do customization. Because as you can imagine, the customization kind of happens from here down. Like this part doesn't change very much, but you can change this to change the HTML that comes out. So I want to explain more about the internal structure of this, because basically the input to the customization process is this XML. So we have something that we used to call the one true tree, which is effectively our schema for all the XML that ends up this stage of the process. It used to be called the one true tree because now we actually support many trees, and we haven't come up with a better name for it. But the tree formerly known as the one true tree. It has some internal structure, which is something like this. This is not complete, but it gives the idea. Okay, so let me walk through this in a little bit more detail. So all trees that end up in stage of processing are a subset of this schema. They all have a root. They all have an application branch. The application branch is where the data that's specific to the original request that came in way over on this side of the board is stored. So when we say, get me my favorites, this is where we put the favorites. Or show me the mail in my in tray, goes here. Or how are my stocks doing today? The stock prices and symbols in this part of the tree. The rest of the tree is boilerplate that's common across all applications, so that all our applications have a common development story. The schema is the same, but the actual data in that schema varies. There's a branch that we call the context, which is stuff about the request, but not things that are actually in the request. So all the fields that are in it get parsed into the tree and put in this branch. The abilities of the particular client box that we're talking to, this guy, get parsed and put in this branch. So if that box has a hard drive, we'll know about it. If it has a printer, we'll know about it. So these are things that help us make decisions about what the final HTML to do or the process to take place. If we ask for it, and only if we ask for it because it's expensive, we can look stuff in the database, either the user or the subscriber or the device or combination, and stick those in the tree as well. And if the URL that came in had some parameters on it, like A equals 1 and B equals 2, then those would show up in the tree as well. And so that almost gets us to the point where we can talk about customization. There's one more thing I wanted to talk about, and that is the synergy that happens between Jinx and ABC. And no one's talked about ABC, so perhaps I should. ABC is another other technology. It's one of those other things that are sort of like engine of the transmission that go into making our applications work. It stands for attribute-based content. And the great thing about ABC is that it's very simple to explain and does what it does very well. So what ABC does is, if you have lots of choices, picks the right one for you. So if you have to decide, should I give this guy Japanese strings or German strings or English strings, ABC picks. Or if you have to decide, is this guy on an ATSC screen or a PAL screen, ABC picks. Or do I use the ATT branding or the WebV branding on this page, ABC picks. So basically, anywhere where we have a number of peers to choose from based on some potentially god-awful logic for deciding which is the right one, what ABC does is a couple things. It isolates decision-making from the rest of this picture over here. This is a lesson learned the hard way from the U.S. service, where all the decisions were baked into the code. Like about 3,000 places on the U.S. service, maybe that's a slight exaggeration, but in way too many places on the U.S. service, had to decide if a user was in Canada. And if they were in Canada, we would put up a Canadian flag in the around town application, and we wouldn't ask for their zip code, we would ask them for their postal code. And we tried but failed to spell favorites with a U instead of, OITS, but that proved to be technologically impossible for us. And a large part of that was because we had a zillion places in the code where we were trying to decide if someone was in Canada or not, and if they were, do one thing, otherwise something slightly different. And the two ugly things that resulted from that are you had the same decision, or the same conceptual decision being made in lots of places in potentially different ways. Like it used to be that we decided if someone was in Canada by looking in this particular over here, but then we found that wasn't sufficient because some guy in northern Montana looked like he was in Canada, but he actually wasn't, so we added this other test for him. But we only got like 299, 300 places where we made the decision the old way. And ABC factors that into one place. The other thing that it does is get all that ugliness out of the code. Like rather than saying, if I'm in Canada, serve a Canadian flag, else serve a U.S. flag, which breaks when you add Japan, because then you have to get else if I'm in Japan, serve a Japanese flag, you just say, get me the right flag, display it. So ABC sort of allows you to strip out a lot of real ugly special cases from your mainline processing and factor it all into these isolated decision files where if you decide at some point in the future that your test for Canadianness isn't sufficient, you can improve it in one place. Everybody makes a decision the same way. None of the other code changes. So that sounds like good stuff, but how does that apply to this? Well, we use it a lot inside this box in Jinx to do the final rendering. And the way we do that is when we draw a particular screen, we divide up responsibility for drawing different pieces of screen into different Jinx files, and we use ABC to pick the right one based on language, the size of the guy's TV, what country they're in, what installation they're in, what type of client they have, and however many other factors we need to worry about. So let me draw that and show how ABC helps us. So here is a canonical screen. We have a sidebar. We have some logo up here, some strings. Maybe it says favorites. Favorites for me. We have some folder tabs, and then a done button. And these have text on them. So there's actually quite a few files that go into drawing this screen. I'll list some of them. Screen, branding, common. Yeah. Page. Sidebar. Okay. list is screen, branding, common, folder list locale, basic page, and sidebar. And what they do is the screen, ABC picks the right screen file, and the screen file defines things like how many pixels by how many pixels. If it's 16 by 9, it's one number, and we've had a very hard time figuring out what that number is, but I think we know now. If it's PAL, it's another one. If it's NTSC, it's another one. So that picks that. Branding is responsible for drawing that thing. I'll come back to common. Sidebar knows how to draw things like that. It has a logo, some buttons, and an identity element that identifies the application. Basic page is even more conceptual. It just kind of knows the idea of something with a sidebar and something with content to the right of it, with a background color of dark gray and text color of kind of green. Common finds the things that are common to all screens in the favorites application, the color of the sidebar, this graphic, a couple of other things. Folder list knows how to draw these artistic little tabs. And it's drawing those based on walking this XML tree. It walks this XML tree, and for each node, it draws one folder tab. Folder list locale knows whether to say favorites for, or whatever the German equivalent of favorites for is. It also knows that even though this is a graphic, or to use the English or German version of the graphic, it also knows how wide to make the star, because in German, maybe not all these things quite fit, and you need to cheat, move this out 10 more pixels so that the big German things don't fall off the end of graphics. And so you can see how, with ABC, picking one of three possibilities here, from our perspective, one of an infinite number of possibilities here, even though a given installation is likely to use only one branding, we have to worry about all of them. One of one here, that's not interesting. One of n here, n is a number of languages. You can get this page built highly dynamically on sort of a large and extensible and variable set of attributes that define the specifics of this request. The other thing is that, hey, maybe you don't like the way I drew a sidebar. Personally, I think it looks pretty good. But if you want it, if you're AT&T, you want it to look like that. If you replace sidebar.jinx and you have ABC pick it based on, whatever your rationale is for deciding when you want sidebars that look like this, so sidebars that look like that, then ABC will pick the right one at the right times, kind of all magically, and everywhere in the system that we draw a sidebar that you want it to be drawn differently, it gets drawn differently. I shouldn't oversell that too much. Sidebar still kind of assumes it occupies like some rectangle on the screen. Like you'd be hard pressed with a jinx file to turn the sidebar into something that appears here and here and here and here in a circle in the middle. Like that's not going to work. But if it's kind of over on the left side of the screen, you can have a pretty good amount of leeway in drawing sidebars differently. Again, sidebars draw based on a certain API. There's a logo up here, some text here, and a graphic here. And you can imagine different mappings of that, and different font treatments, different graphic treatments to produce different results. So given all that groundwork, I can spell out the customization story with a more complete picture. So there's really three types of customization that we can do. There's really simple customization, which is just changing the branding. That's good for trade shows and for partners who want to get something up and running quickly. There is skinning, and then there's using the app APIs. So branding is going all the way back over here. Apologies to the cameraman. Use ABC, pick a different branding file. The branding file implements a different set of Jinx templates that draws the logo where you want to draw it. This file actually has about, I think, 6 different templates that represent 6 different treatments of the logo. How it appears on this page, how it appears on the home page, how it appears on the registration pages, because it's slightly different. It's not just a different file. It's how you place that in a table cell and the spacing to center it and make it look nice. But if you rewrite those 6 templates, then you can put your logo in there. So this is pretty straightforward. And you can also do different things, like if you want to change colors, then you can use Jinx to pick a different set of colors. Skinning is what happens if you want to achieve a more substantial change in the appearance of an application. And so what that means is, getting back to this diagram, you have the same XML, which was computed in the same way by the same engine here. So the car still has the same transition, and it's not going to go from a 4-speed to a 5-speed. But you can strip off all the panels and paint it purple if you want. That's what skinning is. You basically rewrite as many of these Jinx files as you need to achieve the desired effect. And again, not going to turn a VW into Ferrari by doing this, but you can turn a VW into something that looks pretty different. And more specifically, and backing away from the overextended car metaphor, the kinds of things you can do with skinning are you can change the appearance of a page pretty substantially. You can add new links. So if you want to add a new link to a page, that's just extra HTML. You put href equals the place I want to go, and you just add that onto the page. You can add new scheduled content using cats. So you can just drop in another region on the screen where you want ad to appear. So if I want to skin this but put an ad here, I could just write some Jinx that says, go ask cats for the ad to go in the space, or the promotion to go in this space. Things that you can't do is change the fundamental client-server interaction or change the page flow. When I click on this button, I'm going to go to the same place. It may look different, but I'm going to the same place. Or change the data model. You can't make new data appear in this tree, which is then going to get drawn on the screen somehow. So you can take the same data, the same page flow, set up differently, add different links, add new scheduled content. And that'll get you pretty far, but there are limits on what you do with Jinx by skinning. And the last thing is application APIs. So all applications work this way. All applications support customization by fiddling with the Jinx file and ABC. And then each particular application has, or many applications have, extra APIs for customization built into them. So centers let you add new centers or add a new partner pull. Best sells at Amazon, that kind of thing, without changing the code. This is all driven by the config file. So it has an API to let you do this stuff without having to sort of get at our proprietary code. Search lets you change the defaults and samples that people get when they get a new favorites folder. This is valuable real estate. People like having their websites put by default into people's favorites, so we let the net optimize this. Search, you can change the XML backend, which means our search application will work with any backend, provided we can give it a URL. It gives us XML that represents the search results. We're building it with MSN, but if you want to use MSN, you can plug in somebody else that all speaks XML. I should point out these are also XML partner pulls. For registration and settings an account, we have a pretty rich API for changing the flow of registration. So if you want to add new screens or ask different questions during registration, do you want to sign up for premium services? Would you like AT&T long distance as well? Want this on one cable? Sort of custom questions that you might want to ask during registration that are specific to NetOp. There's some extra APIs over and above all the stuff that let you do that in these applications. Okay, questions on this? Yes.
Two questions. One is, you go through branding, skinning, and the apps APIs to change something. What happens when you want to move to server 2.0 to NetOp? Is it pretty transparent?
Yeah, we had an interesting meeting on that yesterday. Basically, it boils down to an exercise in change control. So what we don't want is people modifying our files in our tree. What we'd rather have is they modify files in their own tree. The system, probably ABC, is smart enough to pick theirs over ours when they've overridden some of our behavior. And then when we roll out a new version, NetOps have a choice. They can either integrate our changes into their files or their changes into our files. But there has to be a merge operation that happens, like any branching of source code, where they've taken a drop, adapted it, and then they have to roll those changes forward. Yeah, and we were working on that yesterday. Jim, I don't remember particulars of what came out of that, but did I capture the essence of that accurately?
Yeah, I mean, the other thing to say about 1.0 is that all the stuff that can be done via pinning can be done by anyone. I mean, all the things involved changes to the core code for 1.0 are being done by the engineering group, and part of the project. Right.
Yeah.
Also, I think you are going to have to dialogue on that. A lot of that's going to come from the work that Stephen does. They're willing to smart.
I think probably also was saying that the customization side applies to the server apps. Customers can build their own website using,
Yes.
ASP.
Yes. And because we have Passport, those external apps, even if they are written using, even if they're running on Unix machines or written, whatever, will have some notion of who the user is. Now, they won't have access to things like the user store necessarily, or other proprietary technologies. But there's nothing to stop people from, there's nothing that says you can't link to Amazon or write something like Amazon and have it tie into a system. Just, that's just the way the web works. Just URLs pointing to somebody else's site. On that subject, I want to talk a little bit about the roadmap for beyond 1.0. So what does Jinx stand for anyway? Jinx stands for Jinx is not XSL, and that name was born out of frustration. Me and Steve Sankey sitting in Seattle airport after flying up to Redmond, discovering that the XSL team couldn't support the changes we needed to have them to be able to use their technology in our product. We had also met with these guys who were on something called Project 42 at the time, who described something that sounded great. So we were sitting up there feeling bad because we had three options. One was use XSL, which wasn't going to work. One was to wait for Project 42, go on vacation for a year, and then use that when they were done, which sounded great, but it was probably a sell to management. Or three was rolling our own thing. So that's what we did. We rolled our own thing, Jinx, which was not XSL. Project 42 now has, I guess, a number of different names, ASP Plus or Com Plus Runtime or Universal Runtime or whatever. Still looks, we met with them a couple of weeks ago. It addresses virtually all of the concerns that we had that prevent us from using ASP and XSL in the first place. It is a descendant of ASP and XSL, just like Jinx. And although it's too early to say that for sure in 2.0 we're going to read all of our applications and build it on top of it, definitely the plan right now is to converge with standard Microsoft technology again, use that for our applications going forwards. So Jinx may not have a very long lifespan, which would be okay. But the goal is to try and find a way to not be in the application framework business very much longer, or at least not to the degree that we have been, and to start taking advantage of the next generation of web building tools that Microsoft is putting together right now. So I used too much time. I apologize. Other questions? Okay, thanks.